The recording is starting.
Let's start. So we know electric field is the force experienced by the test charge. Electric field is the force experienced by the test charge. Electric field, a vector quantity, and direction of electric field for positive charge. Unit positive test charge, which is very small, very small. Direction of electric field is from the positive to the negative side. Okay, that's why if you consider formula, electric field is also like kq by r square. What is capital Q? It is source charge, main charge source charge. Example here, you can see the electric field at P point is this. You have to calculate charge at this sphere and it is present at this radius. Diagram is also given. So you can calculate direct by using formula. E is equal to kq by r square. You can calculate q value. Okay. Don't hesitate if you feel that I am quick. You can stop me, sir. Please give me slightly more time to write. But write fast. There is a special concession for Barinder. Barinder, तुम ठंड में रहती हो ना ज्यादा.
Yes,
हाँ. So only for you because it's very cold. Huh. So come to the electric field lines. Always start from the positive and at negative. Electric field line make tangent and tangent show the direction of the electric field. What does it mean? Example, if electric field line is like this, then if you draw tangent, example at this point, you draw tangent like this. This tangent will give you the direction of the electric field, how electric field is moving. Two electric field line never intersect. Why? Because when you take two electric field lines and if they intersect, they will form two different direction at single point, which is practically not possible. At one given point, you can be only at one point. You can't be at 2 points at the same time. So now two electric field line never intersect. Next, electric field line never form closed loop. Why? Because you know inside the conductor, electric field is zero. Next, electric field line are perpendicular to the surface. How? See this diagram. This is any surface. So if you take electric field line, it will be always perpendicular to the surface. Okay, see 90 degree to the surface. So electric field line always enter or emerge from the surface exactly at the 90 degree. Okay, then if you have unlike charge means one positive, another negative. This is unlike charge. Then they will contract lengthwise. And in case of like charge, they will exert sidewise pressure. I will show you this diagram. Maybe I have drawn. Let me check. No. So I will show diagram. This diagram is important to understand, not to write. Electric field line in like and unlike charges. You can see this. So in case of like charge, when two same charge, electric field line try to repel each other, but still it is perpendicular. For positive charge, it is going away. But if you say unlike charge, one positive, one negative, if you are going away from the center, distance is increasing. So draw two, three line. Don't draw all. Draw two, three line to have the clarity how this happens. Because sometimes if examiner want to give you easy question, they can give this also. You never know. It is basic thing, but still we should know. Okay. See here, you know, from positive to negative, it can go. From negative to positive, it cannot because direction will change. From positive charge, electric field line always go away. For negative charge, always enter. So closed loop like this is not possible. Okay, this second part is not possible. That's why we are saying ki closed loop is not possible. Why? Because in case of positive charge, all the electric field line go away like this, and in case of negative charge, it will enter like this. But here, it is entering in the positive charge, which is wrong. Correct? It is entering in the positive charge, which is wrong. Electric field inside the conductor is zero because no charge. Example, if you take this surface, and you have charge on the surface, what is the charge inside the conductor? Zero. Then what will be the electric field inside the conductor? Will be zero. Understood? So inside the conductor, electric field is zero. Why electric field zero? Because there is no charge. Electric field is always because of the charge. And second reason, in this case, charge remain on the surface of the conductor, not inside. In solid sphere, you will have electric field. In solid sphere, you will have electric field. You क्या मांगा आपने? बहुत बढ़िया. मौज कर दी थी ना तू? ठीक. Understood, guys? Anybody have doubt? Am I going too fast, or you can understand each and every stuff?
Sir, I can understand.
Okay. Barinder,
Yes, sir. Understand.
Anvita, Anvita, are you there?
Yes, sir. I'm there. I'm there.
Are you there?
Yes, sir.
Feeling drowsy?
No, sir. I'm just not feeling good. I have a headache and stuff, so not feeling well.
Okay. So whenever you will get time, so take proper rest.
Yes,
It's
sir.
okay if you don't
I'm
read much, but
writing right now. Is that fine?
yeah, yeah. But
I'm there, sir. I'm
remember
listening.
one, if you just listen, na, you will be bored and you won't feel good. Keep writing something. Okay? Important formula. Next, dipole. In case of dipole, you know there will be minus q and plus q charge. Minus q and plus q charge. And we are considering any distance between them. That's how dipole. Dipole means you have positive and negative charge with some distance. That's why when we talk about dipole moment, we consider both the factor charge as well as distance. Vector quantity. Direction is negative to positive, opposite to electric field. Electric field was positive to negative. This is negative to positive, ulta. And unit, you know, charge is coulomb and length is meter. So coulomb meter. And remember, this is not centimeter. This is not centimeter. Dipole moment will be zero, non-polar molecule, dipole moment zero. When net dipole moment in all these situation is zero, because today we'll start the chemical bonding, and you know, in case of chemical bonding, in case of chemical bonding, all these molecules have zero dipole moment. Even I can add more, BCl2. How do we know here dipole moment is zero? Example, if you take CO2, Yes. So this oxygen is withdrawing electron this side. This oxygen is withdrawing electron this side. Net moment is zero because both are equal. Correct. Example: if you are the favorite person in your family, like for your mother and father, and your parents from both sides with equal power say कि she is my favorite daughter, or like she is my favorite person. So what will be your net movement? Zero, because both are putting equal force. Okay, net movement will be zero. Same thing happen in this case. What is the name of this rope pulling game?
The tug of war.
Yeah, tug of war. Correct, tug of war. So in this case, if both are exerting same force, net movement will be zero. That is zero dipole moment. Okay. So same thing happening, dipole moment is zero. In case of polar dipole moment, it means polar compound has some electronegativity difference. Example, not only this, even if you take HF, fluorine is more electronegative, so electrons are moving only in one direction. HCl or many other compounds, not only this. There will be some dipole moment. And all these things are given in your chemical bonding. Here, you have one charge. I will not talk about number. Another charge. A is present at some point, some coordinate. B is present on the another coordinate. You have to calculate what is the total charge and total dipole moment of the system. You know total charge will be zero because here you have positive, here you have negative, net is zero. Understood? Net charge will be zero. What will be the dipole moment? Distance between them. You know, here it is minus 15. Here plus 15. Total distance between A and B will be 30 centimeter. Total distance will be 30 centimeter. If it is 30 centimeter, then you can calculate the value. Correct? So what will be the major concern to understand here? You will make mistake to find out total distance between them. One is negative side, another is positive side on the z axis. So your dipole moment will be present in the z axis. Okay, z axis. Next, if you take on the axial line, here we have negative charge, here you have positive charge, and distance between them is 2l. So and that's the reason why in many book you will take 2l or 2a. Why? Because it's easy to consider from the center. Center is present at L distance from A or B. Center is present at L distance from A or B. Example, P is the point where we want to calculate net electric field. P is, I will focus more on the understanding rather than derivation. Uh, Here it is L. So what will happen when you have this P point? You know this is unit positive test charge. This is unit positive test charge. This positive charge will repel the P point. That's why you can see here direction of electric field is outward. But negative charge will attract this. That's why this is inward. Okay. So if you calculate uh, electric field because of B point, what will you do? You will take charge plus Q and distance x minus L. Why? Because you will consider only this distance. Okay. If you calculate because of A, then you know you will take x plus L because total distance from here to here. Make sense, guys? X plus L. Total distance if you calculate electric field because of A. And these two electric field are opposite in direction, so there will be minus sign. In general, you add electric field. Example, if you calculate total electric field, it is E plus and E minus. But because their direction is opposite, that's why you will have negative sign here. Make sense? Because their direction, that's why it will be negative sign. All other are the mathematical calculation that you can do if you do mathematical calculation. But method will be same. First, you will calculate E positive. This part, Sarah, I'm doing only for you. If you calculate E positive, how you will calculate K, Q, Y? What is will be the distance from the plus charge? X minus L ka whole square. If you take E negative, then K minus Q divided by X plus L ka whole square. And then you calculate net. Further will be only mathematical calculation, nothing else. Understood, guys?
Yes, sir.
Uh, So, if you calculate everything, then it will be 2px, x square minus L square in the P. P point means you are calculating for axial, remember. This is only for the axial. Okay. In case NEET asked both type of question, proper pure form and this special case. This is special case only when x is too much bigger than the 2L. Example, your 2L distance is 10 centimeter and x is 5 kilometer. So you can ignore 10 centimeter in front of 5 kilometer. Okay. So if you take this, then you know you can ignore L square completely because it's very less. It will be x raised to power 4. In numerator you have x. Ultimately, it will be this. Anybody have doubt? Let me know. Understood?
Yes.
Next, in this case, if you consider what will be the direction of electric field, Anvita? Negative to positive, A to B, as you can see in this arrow. A to B. If you see charge is same from positive to P, distance is less, and you know electric field is inversely proportional to the distance. So if you decrease distance, electric field will be more. So Brinda, tell me which one electric field will be more, E positive or E negative?
E negative.
E positive, because less distance, na? Less distance means more electric field. Any doubt? Any doubt, Barinder? Because less distance, more electric field. Because charge is same. You know, electric field directly depend upon the charge, inversely depend upon the distance. Charge is same in positive and negative. What will be the variable factor? X. Less distance, more electric field. Barinder, any question?
No, sir.
So if electric field in the right hand side, dipole moment from A to B, can we say this dipole moment and electric field have same direction, 0 degree angle between them? This is important NEET question. Got it? Done. So what you need to understand in the equatorial point concept, how it is working. Second, Formula ultimately we get after derivation. And third thing, here electric field, if you consider dipole moment, inversely depend upon the x cube. Okay, done. And fourth point, ki both dipole moment and electric field are in same direction. Got it? Second, equatorial line. Same concept, focus on the diagram. Here you have at A point minus charge and B plus charge. In this situation, what will happen? At Q point, you have test charge. At Q point, you have test charge. Now, A negative charge will attract it. So, E negative direction will be this. B will repel test charge because positive charge, both positive charge. This is repulsion. What will be the net electric field? This. It's like resultant force. You know, if you calculate EQ in this case, it will be like E positive square, E negative square, and whole under root. Makes sense? Because the resultant we are calculating. मैं आऊंगे. Understood, guys? Because the resultant here, see, in last situation, both were in the same direction. That's why you are taking plus minus only. Here, they are perpendicular to each other. That's why we are taking square root. Understood? Understood, guys?
Yes, sir.
Second, if you see net electric field is on the left hand side as arrow show, and dipole moment direction is always from the negative to positive, always from the negative to positive. So can we say both are opposite to each other? Electric field on left hand side and dipole moment is right hand side. That's why angle between them is 180 degree. Angle between them is 180 degree because your electric field is like this, E, and your dipole moment is like this, P, and both are 180 degree. Okay, if you use this method, square root, then only nothing you have to do, only derivation, and this time both value will be exactly same. Okay, distance is same. Also, when you consider this P point from A have angle theta, P point from A have angle theta, and this dipole moment have total length 12, so it will be L. This will be X. You can calculate this distance A to Q, and this A to Q will be equal to AQ will be equal to, let's take this O. AO square, it means L square, OQ square, X square, under root. That is one method. Second method, if you want to calculate, you can use sine theta or cos theta. That is also one method. If you take cos theta, cos is base upon hypotenuse. So base is L upon hypotenuse AQ. Depend what is asked. So you can use everything. I taught in every subtle way. If need ask question in the concept wise. Okay. Otherwise, this is the form. Why? Because first you take normal x square and then under root. Like E positive and E negative value will be like this only. E positive and E negative value will be exactly same this time because distance is same, charge is same. And if you take total Q means in the equatorial point we are talking about here. In equatorial. So you will say ki x square plus L square a whole 3 by 2. But if you take special case, again situation is same. But remember here we don't have to. Everything will be same, but we don't have to. Okay. Tell me everybody, any doubt? This is summary. Anybody have doubt? Chandana,
No,
Anvita,
No, sir.
Anvita, Barinder,
No, sir.
Sara.
no, sir.
Yeah. So this is a summary of what we did. At axial point, if you see, it will be 2kpx by x square minus l square the whole square. But here you don't have 2. Everything else is same, but you don't have 2. Second, x is not there, but instead plus sign and 3 by 2. Okay. Second, if you take this common situation, ki x is too much greater than 2l, then here you will have 2. Here it will be 1. Everything else will be same. Can we say at your axial point, it is double of the equatorial point, just multiplying with 2. Right? Because Kp by x cube is electric field at equatorial point. E means equatorial. Equatorial. A means axial. Okay. So Kp by x cube is E, and you can calculate. Third difference. Here electric field and dipole moment have angle 0, and here electric field and dipole moment have angle 180. These are the difference. Okay. Then this is at any point. If you calculate at any point, what will be the situation? This is again dipole. Dipole have minus q plus q. At any p point, we don't. It is lie between axial and equatorial. And let's think, it is having angle theta with the dipole. Direction of dipole moment will be same, negative to positive. You know this axial line look like cos and equatorial line look like sine. Correct? E1 is like axial, and in axial you have cos. And E2 means equatorial. Here you will be having E2. Here you will have E1. So in E2 you will have sine, but look like exactly equatorial. And how to calculate resultant? You know method of resultant. Method of resultant electric field is E1 square plus E2 square whole under root. Understood? Just take square. Here 2 cos square theta, like 2 cos theta the whole square, and here sine theta. Okay. So what happen if you calculate total electric field? Kp by x cube will be common. In first situation, you have E1 square means 2 square 4 cos square theta is cos square theta. Plus in second situation, it is sine square theta. Okay. And second formula we are using here is sine square theta plus cos square theta is equal to 1. So sine square theta will be equal to 1 minus cos square theta. Understood? 1 minus cos square theta. That's why if you put the value of sine square theta, you will get the answer. Example, if you put here instead of sine square theta, you write 1 minus cos square theta. You will get this answer according to formula. Understood, guys?
Yes.
Yes, sir.
Right. So this is at any point. So at any point, you just need this formula, but more than formula, you should know how we came up with this. At any point in board usually asks in the long, but here it is one of the most easiest part. The whole ring have charge, and at one point you are calculating. It's like you have ring in your hand, okay, and then in front of this ring you have any P point. You want to calculate at P point what will be your electric field. So what will happen because of the P point? It will be repelling the charge because here you always keep test charge, correct? You always keep test charge. Test charge will be repelled by the positive. So this will be the direction of net electric field. If this point is making theta angle at P, then this will also be theta. Then this will be cos theta. This will be sin theta. What will happen? Because of the, if you take another point from here, so this will be DE. There will be two components, D sin theta up and D cos theta along the line, correct? So this sin theta will cancel out each other. Only factor that will have DE cos theta. Any doubt, guys? Second point, we will consider this distance, not this distance, not x, because we are calculating from P point to Q point. This is Q, right? We are calculating from P to Q. So you will take this distance. What will be your DE value? K, charge is Q, and distance is x square plus a square. Any doubt, guys? How it is x square plus a square, not under root? Anybody have doubt?
Yes.
Sarah, you need explanation for this?
Yes.
Yeah. So, I will write this again. We know formula of electric field in general is KQ by R square. KQ by, what is R value in this case? X square plus A square whole 1 by 2 because under root. The whole square.
Okay.
Okay, this is the value given, X square plus A square under root. And but here, understand key here you have R square. So square and 1 by 2 cancel.
Okay, sir. Got it, sir.
So that's why this is X square plus A square. What will be cos theta value? Here, base upon hypotenuse. Cos theta value will be base upon hypotenuse. What is the base? X. What is the hypotenuse? X square plus A square whole 1 by 2 under root. Correct? That's why this is given. What is? So you can see here, this is 1. This is half. Can we say it will be 3 by 2? 1 and half, 1 and half. Understood? Done
Yes.
for the ring. Torque is very popular topic. We have 3 questions from the torque and all are extremely easy. Torque is normal formula from the rotation motion. Torque is equal to R cross M. Okay. If you are having this dipole, so what will happen? This is the direction of electric field. This is the direction of electric field. And when electric field will exert some force in perpendicular distance, so in perpendicular distance, you need this distance because this is perpendicular distance. Makes sense? According to the line, this is perpendicular distance BC. BC. So you want to calculate what is this BC value. You will apply this formula. Sine theta is equal to perpendicular upon hypotenuse. Perpendicular is BC, hypotenuse is 2L. So your BC value will be this. This is perpendicular distance. Second thing you need for the torque is the force. How to calculate force? You know electric field is equal to force acting per unit test charge, and force will be this. Correct. Apply formula. Torque is equal to this is R, this is F, and we said R cross F. Correct. This is R, this is F, R cross F. So what is Q into 2L? Dipole moment. So it will be torque is equal to PE sine theta. Why sine theta? Because this is also equal to RF sine theta. In case of cross, you have sine theta. In case of dot, you have cos theta. Any doubt, guys?
No, sir.
You have three cases. Example, if your theta is zero, if your theta is zero, it means this dipole will align like this, A to B, along the electric field. In such case, there is no perpendicular distance. R vector will be zero. No perpendicular BC will be zero. Then your torque will also become zero. This situation is known as equilibrium, highly stable, no rotation at all. Okay, it will be highly stable. If you take 90-degree, it means if you keep your dipole from A to B like this is perpendicular against electric field. So what will happen? Torque will be maximum. Your BC value will be equal to 2L maximum value. So torque will be maximum in this situation. And if you take angle 180-degree, like electric field direction is this, and this is AB. Dipole moment direction is ulta. Both are opposite to each other. Angle will be 180 between. Remember what we are considering? We are considering the direction of the dipole movement and electric field. It will be 180-degree, and sine 180 is also zero. So at 0-degree angle and 180-degree angle, in both situations you have equilibrium because net value is zero, so equilibrium. But there is a difference. If you try to change the position of 0-degree in first case, this is case first, second, and third. If you try to change the position in the first case, it will remain same. It will remain in equilibrium. But in the last case, this one, it is unstable. Why it is unstable? Because if you slightly change the position, it want to come to the 0-degree angle. Understood? Any doubt between this?
No, sir.
Huh. Work done, because you know work done is the scalar quantity, and in scalar quantity, work done is a scalar quantity, and in scalar quantity you have dot product, and in case of dot product you have cos theta instead of sin theta, right? Anything, if you take any quantity, let's take C is A cross A dot B, it will be equal to AB cos theta. That's why it is from theta 1 to theta 2. Got it? But method is same. Here we are having P and E. And electric field is done, guys. I will finish electric flux today. Like this full chapter, electric charge and flux. How is it going as of now, Barinder,
So good.
Tara,
Good, sir.
Anvita?
Good, sir.
Chandana.
Good, sir.
Huh. So, very last topic, important topic, and then we'll be done. Then we'll solve question from every single topic in this chapter. Okay, these are the extra points, some question. We will not discuss these questions. No, we need to do because these are important questions. Yeah. So it will take half an hour to finish, but we can give more time to the numericals. What do we mean by electric flux? How many electric field lines present in a surface or passing through a surface is what we talk about flux. Okay. Same electric field line, but in a given surface. Remember, this ds is area vector, not area. This ds is area vector, it is not area. There is a difference between area and area vector. Example, in this ring type structure, this is area. But if you take perpendicular to this, will be area vector. Perpendicular to this will be area vector. So this is area and 90 degree to this is area vector. Trust me, you will feel confusion only in the direction, not in the formula. Formula is extremely easy. Okay. And because you have dot product, I just told you AB cos theta in case of dot product. In cross product, sine theta. What happened to Pratigya? Why she is not joining class? Let me call her. She must be having college. Jordan went to coaching. She's not picking up. It means she's in college. अरे तुम क्लास अटेंड नहीं कर रही हो प्रतिज्ञा? अरे अगले 9 दिन तो बहुत ज्यादा ही प्रेशर होने वाला है यहाँ पे से। तो आज में जो करना है कर लो, अगले आगे से नहीं करना है ये। अरे और अगले 9 दिन में जो हम पूरा सिलेबस खत्म कर रहे हैं उसका क्या करें? बस ये आज कर लो इस ये एग्जाम। नहीं नहीं, वही तो कह रहा हूँ मैं, 4 बजे तक करोगी तो तब तक हमारी 2 क्लासेज हो जाएंगी। तो इसलिए करना क्या है, ये आज कर लो। अगर कोई बात नहीं, एक बार घर वालों से मैं बात करता हूँ आज। ऐसे तो दोनों तरफ से लॉस हो जाएगा, कहीं के नहीं रहेंगे, ठीक है। तो मैं घर पे कॉल करता हूँ और क्लास ही अटेंड करनी है क्योंकि बहुत ज्यादा काम कर रहे हैं हम अगले 8-9 दिन में, ठीक है। अरे तुम तो एफर्ट डालोगी, लेकिन अगर तुम्हारे पास टाइम ही नहीं है तो फिर यहाँ पे भी तो 2-3 घंटे काम, 4 घंटे का काम हो। चलो मैं आज घर पे बात करता हूँ। हाँ। सानिया इज ऑल्सो नॉट टर्निंग। लेट मी कॉल। कहाँ भाई साहब? आओ आओ। Sanya is also in coaching. Chandana, do you have any exam from college side?
Sir, only practical exam is left.
When?
Sir, I don't know.
But don't miss any class, especially in next 10 days, like
Yes.
up to 20 at any cost. So, come to this point. This is extremely important point. That is why it is encircled. It is always perpendicular. It's not surface. It's not S. It is unit vector, which is perpendicular to the surface. Okay. So if theta is 90, you know cos 90 value is 0 because both electric field will be in the same direction and surface area will be in the same way. Correct. So what does it mean? This is area vector. And imagine if electric field are in 90-degree like this. Electric field is like this. What will happen? Your electric flux will be 0 because they are passing through. You just take a plate. You take your mobile. If electric field are perpendicular to the surface, I'm not talking about surface area. Just imagine simple thing. Perpendicular to the surface to your mobile phone, then all electric field line pass through it. You will have maximum electric fields. Make sense? Now you rotate your phone at 90-degree angle. You rotate your phone at 90-degree angle and pass same line. All the line will pass through the this. So what will you say? You will say ki in this situation, electric flux will be 0. Understood or should I explain this again? You take your phone, take your pen. If your phone is perpendicular to the pen, pen is like electric field. Phone is like surface, not surface area, surface. So maximum line will pass through this phone. Easy to understand? Okay. But now you rotate your phone at 90-degree and keep pen in the same direction. What will happen? Your pen will pass on the side of the phone. कुछ emergency तो नहीं थी कुछ emergency तो नहीं थी कुछ emergency तो नहीं थी So what will happen? Your pen will pass through the phone. So no line will pass in your phone. It means electric flux 0. Understood or should I turn on video and then explain?
Sir, can you explain the second one?
First one, take surface of phone, pass a line perpendicular to the phone. Line will pass through it, maximum electric flux. Correct? But if you rotate your phone at 90-degree angle, okay, 90-degree angle. Now your phone is in front of your eyes and your pen is coming from this side. So pen will pass through the phone. Sorry, pass from this side of the phone. Pass from this side of the phone. So no line will enter into phone. Electric flux 0. Understood?
Yes, sir.
Everybody understood this? That's why, trust me, only confusion you will have how this angle is given 90-degree. This 90-degree angle is not from the area and electric field, it is from the area vector and electric field. I explained you through area because through area it's easy to understand. Area vector it's difficult. Right? But if you don't understand, don't worry. Let me know. I will explain through the video. It will be very easy, extremely easy. So next, Gauss theorem. Gauss theorem says that if you want to calculate electric flux, it will depend upon the electric field and area vector. DS is not area vector. It depends upon the amount of charge present inside the surface. So if you have charge inside, then if you have charge inside, what will happen? It will be responsible for electric fields because there is something. Imagine no charge inside in this sphere. Charge charge inside is 0. Then in this case, electric flux inside will be electric field will be 0. If electric field is 0, electric flux will be 0. Make sense? Understood?
Yes.
So it depends upon the amount of charge. किसने देखा भाई? किसने देखा भाई? नहीं सर जरा आगे पूरे यहाँ आजा आजा. हाँ उस बारना मगो उसे बारना मगो. Understood guys?
Yes, sir.
Now you can prove same electric field by using this method for the spherical surface. Example E dot ds q is equal to q into epsilon. You know for sphere area is 4 pi square. And imagine you got the same form of the electric field. What we studied force by q naught and getting the same form using Gauss law. Now tell me, it's easy to apply Gauss law because charge will be fixed, epsilon naught will be fixed, ds will vary, and you can calculate electric field. In this situation, remember there are few factors that will be important. Maximum charge can be given in the form of like either like lambda L or delta sigma area or rho into volume. Correct? That is the one possibility. Second possibility, instead of mummy tane bola shayad, instead of epsilon naught, you can have epsilon. So it will be epsilon and epsilon are relative permittivity or epsilon into K. Coulomb's law. Third thing, area. You should know how to calculate area of different area of the triangle, area of multiple. Okay, understood? That is the only three things you can be asked from this topic, Gauss law. Everything will look easy if you understand this three things. Key, because you have to integrate the area vector, so you have to calculate value. Charge can be given in the linear charge distribution, surface charge distribution, or volume charge distribution. And third, instead of epsilon naught, you can have epsilon for a given medium. Nothing else can be asked from the Gauss law, and Gauss law is done. Complete. Look easy now. Whatever will be asked, it will be asked only in the three different forms. Either you should know what is the area, what is the charge, what is the epsilon naught, because then you can calculate electric field. Trust me, this is sufficient for the Gauss law. Everything you can do, remaining whatever will do is just application of this Gauss law in the same way. Look easy, Anvita.
Yes, sir.
Barinder,
Yes, sir.
Sara Ali Khan,
Yes, sir.
Chandana Rastogi.
So she's not here.
She's not here. What happened to her? She will join again then. Yeah, she's not here. You know, nowadays I am so confident about all of you guys that I don't even care nowadays because I know if somebody is not in the class, they will definitely join. I don't need to call everybody, ki, oh, join the class. No, nothing. This is the best part. Now, remaining thing is just application part. Imagine if, where is pen? Huh. If this is the electric field and this is the area vector, because see, this is the surface, this is area. Okay, 90 degree to this area vector. And we have angle in when we say na ki it is flux is equal electric flux is equal to E dot ds into cos theta. Remember this theta is taken with reference to the electric field and surface area vector. Correct? Area vector. Area vector. Not area. Area vector. this is angle. Because I know where you will make mistake. You never do mistake in the formula, remember. More or less. Maybe there you might forget one or two formula. You never do mistake usually. You do mistake in the concept from where we are taking angle. And then you feel even if you're getting wrong answer in physics, it is usually opposite. You took 90-degree angle, but there was actually 0-degree angle. And then you feel, oh, how I could do mistake. Actually, it was blunder mistake, but we feel it is a silly mistake. Does it happen, Barinder?
Yes, it happened.
Anvita,
हाँ sir.
Sarah?
Yes sir.
So we have to address this. Everybody is trying to mug up the formula. Ki, oh, I will mug up formula and then everything will be best. No, every single person who is serious about the need, at least they will remember formula, even if they are worst in the physics. They know ki if I do formula, I'll do at least 20-30 questions, if not all. But still, they don't reach up to 10 net after mistake. Reason? Because they feel they won't do any other mistake. But in reality, they will do mistake in the from where you are considering. If you know how I have to measure anything, your 90% things are done. Okay. Here, how in this case, see surface here. If you have charge, then 90-degree to the surface is electric field. Right? Electric field or outward. Electric field is outward. So here angle is 90-degree, cos 90 0. Here electric field outward, area vector will be outward because always 90-degree. Angle in this case 0 and cos 0 value 1. Here same thing. Angle is 90-degree, so electric flux here will be 0. Electric flux here will be 0. Here electric flux will be maximum. So considering all the situation, you will have electric flux only because of C part. Understood, guys? Just imagine if you know this, what in the long road, what is the charge? Lambda into L, I already told you. What is the area of cylinder? 2 pi RL. Write it down. Area of cylinder. Area of cylinder A is equal to 2 pi RL. So L will be cancelled. You can calculate. Tell me, when you know you have to do only this thing. Oh, one more thing you need to take care about in this angle cos theta. Okay, you need to take care about cos theta also. So I will write one thing here to make it better. Either you will have issue in electric field, you have to always calculate area vector and cos theta. Correct? Area vector and cos theta. So just you should know what is the cos theta because if angle is 90-degree, if theta is 90-degree here, cos 90 is 0, then your electric flux will automatically will become 0. Doesn't matter whatever your value is. Understood? So theta is equally important. And same thing happened here. Here theta is 90-90 at both places. That's why electric flux is 0. That's why we are considering only for this part, only for C part. Tell me guys, now you feel it is difficult or you need to do derivation? Yes or no?
Understood.
Yeah. Next, if you take thin infinite plane sheet, thin infinite plane sheet, you will consider both the surface. See, here electric field outside, area vector always 90 degrees. Electric field outside, area vector is 90 degrees. Okay, and I told you charge can be given into the length form or area form. See here, I told it can be given in the length form, it can be given in the area form, it can be given in the volume form. In cylinder, we use length form, delta L. Here, we use area form, sigma into A. But most important thing in this case is this 2. I will mark with this color. Most important thing is this 2. Okay. Most important thing is 2. Because when you take infinite sheet, you take both sides. That's why 2 is most important thing. If you take finite sheet, then you will consider only one side. For finite, one area. For infinite, both the sides. Very important, extremely important. Difference between infinite sheet and finite sheet. I will change this color. This color is good other than pink. Yeah. Any doubt, guys?
No, sir.
Chandana, you are back? When? How?
Sir, I had some network issue.
Okay. So you miss anything important from the last topic? See,
Yes, sir, I missed infinitely long.
infinite, long, thin straight road. It is like cylinder. Huh. Before writing, go through it, ask your doubt. What I did here in infinitely long sheet, instead of area, I wrote 2 pi RL. In infinitely long road, lambda L, and this. Second thing, in case of this B point and A point, because angle is 90 degree between area vector, so that's why your electric flux will be 0. This is what I taught. And you already know area of the cylinder is 2 pi RL.
Yes, understood.
Understood? Now you can feel key whatever I said last year. You need to focus on 3 things. Either you charge, electric, the permittivity, and area. Here area is 2 pi RL and charge is lambda into L. And as simple as
Yes,
that. Thin spherical cell. This is too easy to do. Outside, you know, area will be 4 pi r square. Charge is same thing. At surface, same thing. Inside, inside charge is 0, electric field is 0. So that if charge is 0, electric field will be 0. These are the 3 options for the electric field. Any doubt, guys? Inside it is 0, surface maximum, and after that it inversely depend upon the r square. Correct? Huh? Jad Mitra. Understood, guys?
yes, sir.
If you miss anything, let me know. This is the important question. You have 15 charges, charge particle. Each have this q charge on x-axis. Okay. And if you want to calculate electric flux, you know charge by epsilon. Correct? I think 9 charge are present on the right hand side. That's why it is written 9. Distance will vary. Every time distance is, I guess, r by 3 between everything. Yeah, r by 3. So you have to do. I have to check this question. Where was this question? I think we don't know complete question because calculating electric flux overall will be extremely easy. Okay, calculating electric flux overall is very easy. Why? Because you have total charge 15 charge particle done. Understood? This is the simplest method. You want to calculate electric flux. How to calculate electric flux? Total number of total amount of charge and absolute value remains same. What what was the given? It's not properly. Oh, sphere probably I guess it was given. Like this spherical shaped structure was given at some distance. That is how it looked like. Anji, क्या करा दिया? हैं? क्या पे? Mystery error. Guys, just give me a few minutes. Solid sphere, distribution of charge. We are almost on pendulum. Finish it, quickly revise. I'll take 5-10 minutes, I guess. But I'll finish this topic completely. Okay. I will take 15 more minutes, not more than that. But it's urgent, so I will stop it here. I am coming back quickly.